Yeah, I'm Stephan Fopeano. I am the organization CTO, and I've been leading the other team that we have with UC Davis. So our project, to give a little background and kind of the importance of it, we mentioned that we provide this free transportation service. And the way we do that is with volunteer pilots. So people who are just recreational pilots, they have jobs, maybe they're retired, we depend on them to look at a list of flights that are available at the moment of these people who need the transportation and choose one that's best for them. And in the past, when we were a lot less technically sophisticated, our approach was to basically show all the volunteer opportunities to all the volunteers. And we may have 200 or 300 flights available at any given time. While some people have the patience to do that and go through those and find the ones that are right for them, which is a rather kind of complicated, multidimensional decision process where they have to decide if a flight is geographically appropriate for them, as well as meeting the capabilities of their aircraft and their schedule. Increasingly, the people that we have on our volunteer roster really don't have the patience to do that. And so as a result, we don't engage nearly the percentage of our pilots that we would hope to. So we're leaving a lot on the table in terms of underutilized resources among the organization. So the idea behind the micro-targeting project is to be able to provide a select few of very targeted, appropriate selections to a volunteer so that they can make an easy decision to say, yes, I'll provide service for this individual. So without the ability to increase our volunteer utilization, we really would not have the ability to scale our operations. So it's a critically important project for us. So I'll turn it over to the team to have them tell you how they've approached that.
Yeah, thank you, Stephan. And we are Team Angel Fly West Microtargeting, and we are also really happy to be here today to do our presentation. We have 5 teammates of our team who are Arjun, Avi, Huijan, Steve, Emmy, and I'm Brandy. I'm the project manager this quarter. So today we will walk through these 4 topics of the contents, and these are introductions of Angel Fly West, the problem statements, our solutions in detail, and also our next steps. And now let me hand over to Arjun to do our introduction.
Hi, thank you, Brandy. So I'll be just giving you a quick overview since Stephan and Anne have already explained what Angel Flight West is. So Angel Flight West is a non-profit, volunteer-driven organization that arranges free non-emergency air transportation for children and adults with serious medical conditions. At Angel Flight West, we match volunteer pilots to people in need with basically who might not be able to fly out due to maybe some financial, some geographical circumstances. Coming on to the next slide, our business problem here is that currently 80% of our flight coordination system is self-service, where a list of flights is given to a pilot and a pilot takes one mission at a time. Whereas the other 20% still require manual outreach, where someone from Angel Flight West contacts pilots and requests them to fill out a mission. This method is not only time consuming, but it also requires a lot of manpower. Our goal at Angel Flight West is to achieve 100% self-service rate, which would in turn save us man hours and also help engage pilot engagement and also help people in need. So now I'll hand over to Brandy to talk to you about how do we help Angel Flight West.
Yeah, thank you, Arjun. So this quarter, we generated 2 paths to help to solve this business problem, how to increase pilots' engagement and also increase the self-service rate. The first project we did is called Clustering Project. In this project, we want to find pilot cluster that matches with ideal mission cluster, which means that we firstly cluster our missions into 3 clusters, and then cluster our pilots also into 3 clusters. And we want to find a match between this group of pilot cluster and this group of mission clusters. And another project we did is called recommendation system project. So instead of match pilots cluster with mission cluster, this project, we want to provide each pilot with a mission list based on content-based filtering method, which means that we directly match up with pilots with a list of mission stats best match with their availability and capability. And again, the goals here is to increase the active pilots engagements and also the self-service rate by providing a better aligned mission list. Okay, now I hand over to Steve to talk about our solutions in more details.
All right. Hi, guys. So thank you, Brandy. My name's Stephen, and I'm just going to talk a little bit about our clustering project. So if any of you are unfamiliar with clustering, think of clustering kind of like organizing grocery items into different aisles based on common similarities. Clustering here is going to basically help us kind of find natural groupings within the data. So in the context of AFW, we're using it to group flights based on factors like passenger weight and distance, and categorizing them by complexity. In addition, we're also currently exploring pilot clustering, analyzing their behavior to better understand their actions and preferences. On our next slide, I'm going to talk a little bit about the results of our mission clustering. All right, so to begin, we start by determining the number of clusters that we want to utilize in our algorithm. We use the elbow method, so that's essentially analyzing the sum of squared errors for different values of k. The elbow point in the graph on the left suggests that the optimal value of k is 3, based on kind of where you can see the bend most. We use k-means algorithm, utilizing the flight and weight distances as our features, and we successfully segmented missions as can be seen in this visual. This approach kind of enabled us to provide personalized mission recommendations based on performance and capabilities of a pilot, ultimately helping us match pilots with flights they're more likely to accept, improving efficiency and satisfaction. Now I'm going to hand it off to our team who worked on our recommendation system.
Hello, everyone. My name's Avi. I'm going to talk a little bit about the recommendation system. So what is a recommendation system? A recommendation system is basically just a machine learning driven tool that's designed to provide highly personalized suggestions to users, right? So I think most of us here are probably familiar with recommendation systems on a day-to-day basis, at least. They're widely used in streaming services like Netflix's recommendation system. We also, Spotify, Discover playlist. And of course, Amazon, which is very interested in showing you all the products based on products you've already bought that you are most likely to buy. So we engage with these on a day-to-day basis, and our goal here was to try and develop something like that for Angel Flight West. And so at the core, these recommendation systems are actually a very data-driven approach to micro-targeting. So very apt for our project and our business goal. And of course, like if executed right, they can have a lot of positive business impacts, improving user experience, boosting retention, and increasing conversions, which drives revenue. For us, we developed what's specifically known as a content-based filtering system. And that's basically that it sort of relies on matching users and items based on attributes, preferences, and behavior. So that's basically if you could just go back one slide. That's the passengers, the weight, and the distance features that we've talked about. Yeah, so just to quickly go over, like for our recommendation system that we built out, the steps that we followed was just a general overview is data extraction, these three main variables of pilot preferences, behavior, and mission data. We did some pre-processing to the data, normalization, which essentially just scales all the data together. The machine learning algorithm really likes it more that way. And we remove outliers to prevent any like skewing of results, sort of distortion of results. And finally, probably the most important is we compute similarity scores, and that's how we actually determine the best missions to show to pilots. So in the next slide, this is just the flow chart, sort of showing the general process of the recommendation system from left to right. Again, extracting from the database, we do some feature engineering in the middle, processing of the data. We compute the similarity scores, and then we just sort them from decreasing. And it provides us a list of top 5, 6 missions to show to pilots. And with that, I will pass it to Hujuan, who will talk a little bit more about the computation of similarity scores. Thank you.
Okay, thanks, Avi. Hello, everyone. My name is Hui Juan. In recommendation system, a similarity score represents a numeric value indicating how closely two items resemble each other according to their features. In our case, the two items are pilots and missions. As we have the features of pilot preference, pilot behavior, and missions, by putting down different weights on different features respectively, we can calculate a similarity score between a pilot and a mission. There are two methods to calculate the similarity score. We select Euclidean distance rather than cosine similarity method because we care not only the angle between the two items, but also the magnitude of the distance between them. Coming to the next slide, we'll calculate the similarity score for each mission relative to every pilot. Finally, this will allow us to provide a personalized list of missions with the highest similarity scores tailored to a specific pilot. Now I'll hand it over to Brandy to tell more about what comes next.
Yeah, thank you, Huijuan. So our next steps will be mainly focused on validations and improvement of our model. So of the clustering project, we will identify some distinct clusters of pilots based on their relevant characteristics. And then after doing that, we will try to find a match between this group of pilots and this group of missions. After that, we will also do a validations of the accuracy of this model. In recommendation system projects, we will finish our content-based filtering, which is generated this quarter, and then we want to validate using A/B testing. After that, we will also try to improve our model using collaborative filtering based on the Google Analytics data. And after that, we will also compare the performance of different models. We are here this quarter at the end of winter, and we expect to finish our next steps by the end of next quarter, which is around May 2025. And thank you, everyone. Let me know if you have any questions.